Okay, so hopefully you guys are able to hear me okay. I'm covering the inverse trig functions today. I actually have a video on this, but I feel like I didn't really do a good job of it, so I'm redoing it, adding more examples, that sort of thing. So just to recap, there are 6 trig functions. We've got sine, cosine, and tangent. And I've put those in terms of whether they're the x or the y on the unit circle. And then we've got cosecant, which is the reciprocal of sine, secant, which is the reciprocal of cosine, and then cotangent, which is the reciprocal of tangent. And then I've got the unit circle here. We will be using this a lot. So the inverse trig functions, they follow a function inverse the definition. So a trig function, you give it an angle and it outputs where it would be on the unit circle, basically. An inverse trig function does the opposite or the inverse. You put in sort of where it is on the unit circle, and then you get out the angle. And we do everything in terms of radians. So your angle is going to be in radians. Make sure your calculator is in radian mode. Now, in order for things to have an inverse, they must be 1-to-1, which means that they pass the horizontal line test and the vertical line test. Trig functions do not pass the horizontal line test. So in order to have inverses, we have to restrict the domain to a spot where they do pass the horizontal line test. And so if you have the domain of a trig function restricted, that means that's akin to the range of the inverse trig function. So we have to take into account the domain when we're doing all of these problems. Now, when we're working with trig functions, we usually indicate the inverse by writing the word arc in front. So the arc sine is the inverse sine, arc cosine is inverse cosine, or arc tangent is inverse tangent. The other way we do this is using an exponent of -1, because when you have an inverse function, the inverse of f of x is f to the -1. So that's the other way that you could indicate that. Calculators tend to use the -1, but I tend to use arc when I write these just because I feel like it's a little more clear, and that's what I say say out loud is arc sine, arc cosine, that sort of thing. So let's just look at the sine versus the inverse sine, or arc sine. So we can either write it as literally arc sine of x or sine to the -1 of x. So x is your input value, and then your output is in radians. So I've got the sine graph here. So you can see it does not pass the horizontal line test. So what we do is we restrict the domain so that the domain of sine is between -π/2 and π/2, because then it does pass the horizontal line test. So because that's the domain, the inverse, that is the range. So the range of arc sine, where values for outputs are from -π/2 to π/2. And then the y values of sine are the inputs to arc sine. So that goes from -1 to 1. So I like to look at this in terms of the unit circle and highlight the part of the unit circle where we have answers. So that way I know where to look, because otherwise it gets really confusing. So arc sine is between -π/2 and π/2. So we're going to be looking for solutions that are on the right half of the unit circle. So just kind of want to color that in. This is where our solutions are going to fall if we're looking on the unit circle. So when we start trying to solve these things, that's the area that you're looking at. So next is cosine, and then how that's related to arc cosine or inverse cosine. So again, it does not pass the horizontal line test. So we have to restrict the domain in order to make it have an inverse. And so we don't do -π/2 to π/2 because that part there, it doesn't pass the horizontal line test. In order to make it pass the horizontal line test, we have to go from 0 to pi. So the domain of cosine would be from 0 to pi, which means that the range of arc cosine is from 0 to pi. And then again, our input values are between -1 and 1. So For cosine, we're looking at 0 to pi. So you're looking at the top half of the unit circle. So that's where our values are going to fall when we start doing the inverse cosine or arc cosine. So it's going to be in the top half because that's where we're from 0 to pi. Then we've got tangent and inverse tangent. So this is actually a graph of the inverse tangent or arc tangent because it has asymptotes, and well, tangent has asymptotes too. So what we do is it's just kind of the tangent rotated and kind of flipped, reflected. So your domain is negative infinity to positive infinity. So we can plug in any number that we want into arctan. It works. But our range is always going to be between negative pi over 2 and pi over 2. But we have asymptotes, so we can't actually get values of negative pi over 2 and pi over 2. So just keep that in mind because those are actual where the asymptotes are. So the endpoints are not included here. So when I graph, what I really should do is not even put a line there and just put a little bit of gap there to show that those endpoints are not included, but anything else is included there. So oops, my highlighting is not that great. Apparently my pinky highlighting. So I keep getting caught on my cord. So the pi over 2 and negative pi over 2, which is the same as 3 pi over 2, those are not included in our inverse here. So but everything else on the right side is included. So when we solve equations with trig functions, we use the inverse trig functions. And that is because they're inverses. The whole definition of inverse is that if you plug one function into the other, they cancel out and you get x. So if you take the arc sine of sine, we're going to get x. Arc cosine of cosine is x. Arc tan of tan is x, and vice versa. You can do sine of arc sine, and those will all cancel out. So when we start solving, which I'm not going to be covering solving in this video, I'm just using these so I can understand how they work and everything. When you actually start solving using the inverse trig functions, this is what we use. We use the fact that they undo each other. And you have to kind of think about the domain and range. And when you get into solving, you have to think about the period as well. So it gets way more complicated. So let's just, start doing functions here. So examples. So we want to find the exact value of the expression if possible. So I've got the unit circle here, but we also need to take into account our range, what our possible outputs are. So we'll start with arc sine of 1/2. So when you're on the unit circle, sine is like the y values. So we're looking for where are the y values of 1/2. So we've got right there, that's a negative 1/2, negative 1/2. So we've got two possibilities, pi over 6 or 5 pi over 6. So those are our two possibilities. And we are trying to find okay, which one is within our domain. So if I go back to our range, our outputs for sine, because this is arc sine, we want all of our values on the right side. So that value on the left is not part of our range. So if I go back here, we had two possibilities. 5 pi over 6 is not part of the range. So pi over 6 is going to be the actual output. So remember, the arc sine gives you like your x or y or whatever, and then outputs the angle associated with that. And we have to take into account the domain. So the answer here would be pi over 6 based off of where it is located on the unit circle. So now let's look at our cosine. So cosine always is the x value. So if we're getting arc cosine of 1/2, that means where's your x value 1/2? So we have an x value of 1/2 up here and down there. So we're above and below. We've got it at pi over 3 and at 5 pi over 3. So We are looking for where we are within our output range. So if I go back to cosine, cosine is the upper part of the graph. So we want the angle that's in the upper part of the graph. So I go back here, and that is going to be pi over 3. So our solution here is pi over 3. So we find the matching angles, and then we pick the ones that are in the correct range or outputs. So next is arctan square root of 3 over 3. So tangent is always kind of hard to find when you're on your unit circle because tangent is opposite of adjacent, which in this case is going to be x or y over x. So you're looking at both the x values and the y values, and you're looking for the ones that will produce square root of 3 over 3. And that is equivalent to if we had arctangent of 1 over the square root of 3, because square root of 3 over 3 is just the rationalized version. So essentially, you're going to be looking for your fractions where the denominator is the same, and then the denominator basically cancels out, and it's going to be the numerator over the numerator for y over x. So when I highlight that, and we want a positive 1 over square root of 3, so that's right here. Pi over 6 is one of our possible answers. That's going to be a negative underneath that. That's a negative. And then if they're both negative, that will also cancel out and give you a positive 1 over square root of 3, or square root of 3 over 3. So because tangent is opposite over adjacent, so you're looking at your y value over the x value. So 1/2 over square root of 3 over 2 will become 1 over square root of 3, which is square root of 3 over 3. So our possible angles are pi over 6 and 7 pi over 6. So now you need to go back to where our range is, what values are we allowed for output for tangent and for the inverse tangent. So that is going to be the right side, but not including the pi over 2. So go back. That means our answer has to be pi over 6 because that's the only one that falls into that section of the graph. So arctan of square root of 3 over 3 is pi over 6. So then we're looking at arcsine. So arcsine of 3. So remember, this is your y value, or basically if you're graphing sine. It's the y value on the unit circle. There is no value of 3 on the unit circle for y because our inputs are only between -1 and 1. So if we go back to the sine versus inverse sine, the domain of arcsine is only between -1 and 1 because that's the range of the sine graph. So if you're asking for arcsine of 3, there is no answer because that's not part of the domain. That is, if you put it on a calculator, your calculator is going to give you error. So what our textbook says is not possible as the output. There gives you an error, it does not exist, it is not part, that can't be plugged in. So there is no value that is going to work there because it has to be between -1 and 1. So next we want to find the exact value again. And this time I'm using the -1 notation just so you kind of get used to it so you can see. We've got two different notations, but it's going to be the same sort of thing. So first one, we've got arctan, or inverse tangent, of negative square root of 3. So we're thinking tangent, opposite over adjacent. So this would be, if it was negative square root of 3 over 1, we're looking for our y value to have the square root of 3, and then our x value to have 1. And then we need to have opposite signs, so it comes out negative. So when you look at your unit circle, At pi over 3, we've got our y value having square root of 3 and our x value being 1, but this comes out as positive. So those are both positive numbers. We want to have a negative. So we will use the other side here where one of them is positive, one of them is negative. And then at 5 pi over 3, one is negative, one's positive. So our two possible answers for tangent here are 2/3 over 3 for our angle, or 5 pi over 3. So if we look at our tangent, we want the 5 pi over 3 because that's in the correct section. But we do have to consider that our domain or our range is from negative pi over 2 to pi over 2. So we can't give it in the form 5 pi over 3 because that's not within that range. So we have to find the negative version of it, the other angle. So we need to subtract 2 pi in order to get the other version of the angle. So what this would be equal to, so first we found this is 5 pi over 3, but we need to subtract 2 pi from it to get the actual angle in the values we want because we're going from negative pi over 2 to pi over 2. So 2 pi is equivalent to 6 pi over 3, so that we have a common denominator. So 5 minus 6 is negative 1. So this is going to be equivalent to negative pi over 3. And now that it's the same angle, but now that's in our range from negative pi over 2 to pi over 2. So that's our value of your arctan of negative square root of 3. So next we have arc cosine of negative 1/2. So cosine is our x value. So we're looking for an x value of negative 1/2. One of them I actually already got highlighted there. And then the other is 4 pi over 3. So we've got 2 pi over 3 and 4 pi over 3. So we have to go back to the range of our cosine. So you definitely want to have these handy. Arc cosine is in the upper half of the graph. So we've got one in the upper, one in the lower. So it's the one in the upper that is going to be the correct answer here. So in the upper, the angle is 2/3 over 3. 2 pi over 3. So our answer here is 2 pi over 3 because that is in the proper section of the unit circle. The next one, we have arc sine of negative square root of 3 over 2. So sine is the y value. So we're looking for a y value of negative square root of 3 over 2. So I've got one of those highlighted. And then negative square root of 3 over 2 is also over here. So they're both in the lower parts of the graph. And so now we have to determine, well, which one is in our range. So going back to our range, our inverse sine is on the right side of the graph. So the only one that's on the right side of the graph here is 5 pi over 3. Now again, we're going from negative pi over 2 to pi over 2. So we need to convert it back to its negative version of the angle. So we actually have already done that work. It's negative pi over 3 because we did it up here. So we don't need to do it again. And so to make sure that it is within our range of negative pi over 2 to pi over 2, we're going to use negative pi over 3 when we refer to this angle. And then we have cosine. So arc cosine of 0. So cosine is typically the x value. So where is our x value? 0. So we've got it up here at pi over 2, and then at negative pi over 2, or 3 pi over 2. And so you go back to your range of the arc cosine, and that's going to be in the upper half. So pi over 2 is going to be our answer because that's in the upper half. So this is going to be equal to pi over 2. So these aren't bad. You just have to keep referring back to the unit circle and then referring back to the range so that you know which of the values you are using, and then make sure that it is within the numerical range, and you have to convert it to the negative value as needed occasionally to do that. So these are a little trickier because we're doing the inverse and then the regular function. So we're kind of practicing that canceling out thing. So again, we're finding the exact value. So we've got sine, arc sine of 0.3. So first off, arc sine, you're allowed to plug in numbers from -1 to 1. So plugging in 0.3 is totally fine. And then because the sine and arc sine cancel things out, you need to make sure that, you have to, you're going to just get 0.3 out. And you have to make sure that it is in the output of sine, because that is the last function that we have going on here. The output of sine is between -1 and 1. So these just strictly cancel out. Your answer is 0.3. We're allowed to plug it into arc sine. We don't have to do any conversions. It's allowed in the range of sine, so they just strictly cancel out. Next is cosine, and then arc cosine and negative square root of 3. So arc cosine has to be between -1 and 1, whatever you plug into that. So, we're plugging in a number, negative square root of 3. You might want to grab your calculator to see, okay, what does that actually come out to? And square root of 3, on the square root button. Root of 3 is 1.7. So this is asking, we're plugging in -1.7 plus some decimals. You can only plug in values from -1 to 1 in arc cosine. So we can't plug in negative square root of 3. It is outside of the allowed inputs to arc cosine. So we can't, this doesn't work. Your answer is not going to be negative square root of 3 because even though the cosine and arc cosine are inverses, we can't even plug that value in. If you try to do that on your calculator, and calculators do have these buttons, they usually use the -1 notation. But if you try to do that in your calculator, you're going to get an error. So again, we just say this is not possible. Okay, last one. Now we're doing arc sine of sine 9 pi over 4. So first we want to do the sine of 9 pi over 4, and then you take the arc sine of that. And now normally these would cancel out. Your arc sine, your sine would cancel out. Your answer would be 9 pi over 4. But for arc sine, your range has to be between -pi over 2 and pi over 2. So we can't say that our answer is 9 pi over 4 because that's not within our range of -pi over 2 to pi over 2 based off of the graphs, because we're looking at the last thing we're doing is arc sine. So we have to look at the output of arc sine because that's the last thing we're doing. And so 9 pi over 4 is not in that range. So we have to convert it into the form from -pi over 2 to pi over 2. So this would be 9 pi over 4, but we have to subtract 2 pi in order to get the correct angle that is within our allowed output, our allowed range. So 2 pi is equivalent to 8 pi over 4. So 9 minus 8 is 1. So our output here is actually going to be pi over 4, because we need to make sure that since our final answer is coming from arc sine, we need to make sure that it matches with the range of the arc sine, which has to be on that right side of the unit circle. So we can't say 9 pi over 4. You have to convert it, which is equivalent to pi over 4. So last 3 here. Again, we're finding the exact value, and these are not ones that kind of go with the unit circle, and they're not inverses. We're not like canceling these things out because I've got sine of arc tangent. So these are not canceling out. My answer is not going to be just 3/4. So for these, you draw a right triangle. This is how I solve these. I draw my right triangle, figure out from there. So I'm going to draw a triangle, and then it doesn't matter what angle that you label, just label one of the angles, theta. So we have arctan of 3/4. So tangent is opposite over adjacent. So the opposite is 3, the adjacent is 4. And then I need to fill in my right triangle. So there's a 3, 4, 5 right triangle. So I could do the Pythagorean theorem to solve for the hypotenuse, and you would find that it is 5. So I filled in my triangle. Now I want the sine of this angle. So the theta, the angle that I've labeled, I want is the sine of that angle. So that is so opposite of our hypotenuse, which is going to be 3/5. So our answer here is 3/5. I should have put my triangle a little bit to the right so I could just done equal. So you build your triangle based off of your input, and then you use that triangle to actually find the trig function. So the next one, we've got cosine of arctan of 2. So I always like to make these at fractions. So tangent is opposite over adjacent, so that's going to be 2/1. It's 2/1. So I've got a 1, 2, and then I need to figure out my hypotenuse. So we use the Pythagorean theorem. So I'm going to use h for hypotenuse. It's going to be 1 squared plus 2 squared. So it's 1 plus 4, which is 5. So our hypotenuse, let's carry down these h squares, is the square root of 5. So I'm going to label that on my triangle. So I've completed my triangle. And now, so we figured out a triangle based off of the arctan. And now I want to find the cosine of that angle. So that's adjacent over hypotenuse. So that's going to be 1 over the square root of 5, which is equivalent to the square root of 5/5 when you rationalize your denominator. So now the last one here, I've got secant of arcsine of 5/13. So draw my triangle, label my angle. So sine is sine, so opposite over, I always have to do SOHCAHTOA. So it's opposite. So the opposite is 5, and our hypotenuse is 13. And then we need to find our missing side using the Pythagorean theorem, or if you happen to know your right triangle, your special right triangles. So 3, 4, 5 is the only one I ever remember. So we use the Pythagorean theorem. So we got 13 squared equals the adjacent side that I don't know plus 5 squared. So it's 169 equals a squared plus 25. Subtract 25 from both sides, you get 144 as a squared, which means when you take the square root, our missing side is 12. So now I filled in my triangle, and now we're asked to find the secant of this angle. So this secant is 1 over cosine. So cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So the hypotenuse is 13 and adjacent is 12. So we end up with our answer here to be 13/12. So this is just gives you some familiarity with the inverse functions, how they work. What's really nice here with these types of problems is you don't have to worry about, you can look at the unit circle, but with these particular numbers, they're not on the unit circle. And you don't really have to worry about the domain and the range, but you do have to worry about those for these types of problems. And then of course, when you're finding your inverse functions. And so what that means is when you're solving using these things, you also need to think about your domain and range. But that's a whole different video. So if you have questions, you know how to contact me. And hopefully you have found this helpful. So thank you guys, and I will talk to you later. Figure out how to stop my recording.